How to divide binary numbers. In this tutorial, we will describe how to divide binary numbers. In the Terms Involved in Math Operations video, we discuss terms involved in division. Since we will be dividing binary numbers, the operands involved in division are dividend and divisor. The result would be the quotient and possibly a remainder. For example, let us divide the following. Okay, we want to perform a division. As we mentioned with division, you have the terms involved, quotients, divisor, and dividend. In this example, we want to take the number 175 and divide by 5. 5 is our divisor, 175 is our dividend, and our expected quotient should be 35. I have a few notes towards the left. In this case here, as we divide, you're going to see that we're going to determine that if I have to answer a question no, then that value is 0. And if that answer to that same question is yes, that's 1. This is also related to the division cycle. You will see as we perform division in this computation, there's a cycle for each working dividend. We divide, next we multiply, next we subtract, and next we extend the working dividend. And that's by bringing a number down to create the next working dividend. Towards the right at the top, try to mimic exactly what we have in decimal system. So the value 5 is 101, and the value 175 is 101,01111. And our value to the top should produce a binary number, and we're going to show in the end that that number is exactly 35. So let's compute. Alright, so as I look towards the left again, I told you, so when we do that first part of the division cycle, when we try to divide, I'm going to ask the question whether that number 5 goes into a particular number. And if that number actually goes into it, then we will say that's yes, and that we'll put a value of 1 towards the top. If the value 5 does not go into a particular number, we'll say no, and that value represents 0 at the top. So let's see. So we start off, our first working dividend is actually 1. So start right here. So we ask the question, and keep in mind this value here, 101, is 5. So does 5 go into 1? The answer would be no. So we put a 0 to the top here. And then our next step of the cycle is multiply. So we got 0 times 5 is 0. And then the next part of the cycle is subtract. So we subtract 0 from 1. So 1 minus 0 is 1. And then we say our last part of that cycle, we want to extend the working dividend. So we bring down the 0. And so that's represented here. Now we have the value 2. Does 5 go into the value 2? The answer is no. So we put a 0 to the top. And then we multiply. We got 0 times 5 is 0. And then the next step is subtract. So 2 minus 0 is 2. And then the last step is bring down or extend the working dividend. So we bring the 1 down. So this gives us a value 101, which is 5. Does 5 go into 5? The answer is yes. So we put the value 1 above here. Next step is multiply. 1 times 5 is 5. 5 in binary is represented as 101. Next step is subtract. So 5 subtract 5, you get 0. So next step is extend the working dividend. It says bring this 0 down. And so we have 0 here. Does 5 go into 0? The answer is no. So we put a 0 here at the top. And then next step is multiply. 0 times 5 is 0. And then we have 0 subtract 0 is 0. And then we extend the working dividend. So bring down the 1. So it goes right here. So we have the value 1. Does 5 go into 1? The answer is no. So we put 0 to the top. And 0 times 5 is 0. And next step is subtract. So 1 subtract 0 is 1. And we extend the working dividend. So we bring down the 1. So 1, 1 in binary is 3. Does 5 go into 3? The answer is no. So we put a 0 to the top. And 0 times 5 is 0. And then we subtract. So 3 subtract 0, you still get 3. And of course we're going to extend the working dividend and bring a value 1 here. So 1, 1, 1 is exactly 7 in binary. Does 5 go into 7? The answer is yes. So we put a value 1. 1 times 5 is 5. So that's a value 5. Go here in binary representation. Next step is subtract. So when you subtract 7 from 5, you get the value 2. So 2 is represented as 1, 0. And then we extend the working dividend. Oops. So we bring the 1 down. And that 1, 0, 1 is the value 5. Does 5 go into 5? The answer is yes. So that means we put a value 1 here. And then 1 times 5 is 5. Then you subtract. And we have the value 0. And that says that we cannot go divide anymore. So let's check to see if we have 35. Let's see. Let's write it out here. So we got 0, 0, 1, 0, 0, 0, 1, 1. And let's look at the positions again. Here we got 2 to the 0th power, 2 to the 1, 2 to the 2nd power, 2 to the 3rd power, 2 to the 4th, 2 to the 5th, 2 to the 6th power, and 2 to the 7th. Remember we said the ones that are turned on, that's what we care about. So let's look at these. And 2 to the 5th power is a value of 32. And then the value 2 to the 1st power is 2. And then 2 to the 0 power is the value 1. And when you add this up, it's the value 35. And this is what we wanted to show. Next, let us perform another binary division. This time we will divide numbers using a decimal point. Alright, once again, we pretty much is very similar to what we had before. We're going to perform division. And when you're dealing with divisions, you got certain terms. Quotients, divisor, dividend. So for this example, we're going to divide the number 176.8 0.25 by the divisor of a value of 5, expected value should be 35.25. The notes below, you saw that in previous examples, so you kind of got an idea how I'm going to use that. If you look towards the right, you will see we have 5 go into this binary number. What this is a binary representation. So inside the bar, we have the value 10110000.01. That represents the value 176.25. And the value 101 is the value 5. We're expecting a binary representation on the top bar should represent the value 35.25. So let's compute. So once again, we start with the working. We always start from the left and work towards the right when we're dealing with division. And keep in mind that there's a division cycle. So usually each cycle starts off with a divide, a multiply, subtract, and then you want to extend the working dividend. So we're going to start off again with 1. 1 is our current working dividend. So we ask the question, does 5 go into 1? The answer is no. So that's a 0. Represent a value of 0 to the top. Next thing is multiply. That's the next step in the cycle. 0 times 5 is 0. And the next step is subtract. And of course we get 1 subtract 0, you get 1. And then we say extend the working dividend. So we bring that down. So we have a value 10. This is a value 2 in binary. So we say we want to ask a question for the next cycle. Does 5 go into the value 2? The answer is no. So that says that the value at the top here would be 0. And the next step is multiply. So 0 times 5 is 0. Then you subtract. And so we still have the value 2. But we also, the next step is extend the working dividend. So we bring the 1 down. And that value is 101, which is in binary the value 5. Does 5 go into 5? The answer is yes. So we put a value of 1 up here. Next step is multiply. So 1 times 5 is 5. So we got 101. Then we subtract. And we get the value 0. And then we extend the working dividend. So we bring down the 1. And so now next working dividend is 0, 1. So we ask the question, or we're going to begin the cycle again. Does 5 go into 1? The answer is no. So we put a value of 0 to the top here. Next step is multiply. 0 times 5 is 0. So we subtract. So 1 minus 0 is 1. And then we extend the working dividend, bring down the 0. Now we have a value of 2. Does the value 5 go into the value 2? The answer is no. So we put a value of 0 to the top. Next step is multiply. 0 times 5 is 0. Then we subtract. That's 2. Subtract 0, you still get 2. Then we bring down the 0. And we start the cycle again. This is a value of 4. Does 5 go into 4? The answer is no. So we have a 0 here. And then next step is multiply. 0 times 5 is 0. And we subtract. And we still have the value of 4. But keep in mind you bring down or extend the working dividend. And that value is 0. So now we have the value of 8. 1000 is 8. And so the next question, does 5 go into 8? The answer is yes. So we have a value of 1 here. 1 times 5 is 5. Then we subtract. And 8 subtract 5, you get the value 3. So 3 is represented as 1, 1. And also you got, at the end of the cycle, you got to extend the working dividend. So in this case, we bring it down to 0. Now we have a value 0, 1, 1, 0, which is the value 6. Does 5 go into 6? The answer is yes. So we have a 1 up here. And then next step is multiply. 1 times 5 is 5. So let's see, 5 here. And subtract. So we have 6 subtract 5. That's a value of 1. So 1 is there, and this is all zeros. And of course we have to bring down, let's try to bring that back. Alright, so we bring down or extend the working directory, or dividend, I'm sorry about that, it's working dividend. So that's a value 0 here. And 1 0 is the value 2. Does 5 go into 2? The answer is no. So we put a 0 here. But also keep in mind, since we're dealing with a decimal point, let's go ahead and put that here. That's where our quotient. We want to keep track that we're dealing with 2 decimals behind the decimal point. All right, so we have the value 1 0. So that 1 0 is the value 2. So we're back to start the cycle over. So for the divide part, we ask a question: does 5 go into 2? The answer is 0. That's what we have here. Sorry, I got a little mistracted here. So that we answered that question previously. So we got 1 0, 1 0. So the next step is just move forward and bring down the 1 for the final dividend extension. So that's the value 101. And so we have the value 101, which is 5. So we ask the question, does 5 go into 5? And the answer is yes. So 1 goes here, and then 1 times 5 is 101. And next we subtract, and we get the value 0, and that tells us we can't go any further. So next we want to just check this to make sure that this value is going to, or the quotient is going to be 35.25. So let's just check. So we got 0, 0, 1, 0, 0, 0, 1, 1, 0.01. And let's look at its positions. Let's see what we have. 2 to the 0 power, 2 to the 1 power, 2 to the second, 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth power, 2 to the seventh power. And as we say, anything to the right of the decimal point, we're going to have a negative exponent. So negative 1 and 2 to the minus 2 power. So we want to look at what we have that are turned on. Anything with a 1 above it, saying that that value is turned on, and that's what we're really computing. And then this last one over here. All right, so let's see what we have. So 2 to the fifth power is a value 32, plus 2 to the 1 power is a value 2, plus 2 to the 0 power is a value 1, and plus 2 to the minus second power is really 1 over 4, which is a value of 0.25. When we add this up, it comes to be the value 35.25. And this is what we wanted to show. This puts us in a position for my next tutorial where we describe the addition of hexadecimal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.